Alright, so for 1.3a, where we're beginning to describe quantitative data with numbers, we have three objectives today. The first one is we're going to calculate measures of center and spread, be able to identify outliers, and then create and interpret box plots. And your essential question as we're going through, I want you to be thinking about, what does a box plot show? So by the end of this lesson, you should be able to do these 5 questions, which all center around those 3 main objectives. So take a minute and look over these and see if there's any that you already know. Alright, so what do you see? When you look at this graph, I want you to analyze it and determine what the average score is. So if you're familiar with the AP exam, you are scored on a scale of 1 to 5. Most schools will accept a 4 or a 5 for college credit. Some will take a 3. So when you look at this graph, I want you to think about what is the average score of Knox County students on the AP Stats exam last year. Alright, so these are vocabulary words that you need to be familiar with for this lesson. We're going to be working through all of them as we move through the lesson. So we have 2 things that we like to measure when we're looking at data. We like to measure the center and we like to measure the spread. So we measure the center with either the mean or the median. And then over here I just put kind of the notation of what we use. So this is mu. It's the Greek letter. It's like a fancy capital M. And it stands for the population mean. So if I'm talking about everybody at AE, then I would use mu because that would be the average of the population, the Austin East. Whereas when I look at a sample, which is what we will mostly deal with, we use X bar. That's what we call it. It's an X with a bar over it. And so that represents the sample mean. So if I found the mean of our GPAs for our class only, we would use that as the sample mean because that is representing the population of Austin East high schools if I was looking for the average of Austin East high schools. So those are the 2 differences. The median, you'll either write out median or sometimes you'll see MED. So for spread, we have range, we have interquartile range, and we have standard deviation. And we're going to explore those a little bit further as we move through this. But for range, we find the range by taking the maximum minus the minimum. We find the interquartile range by finding the range between the 2 quartiles, so Q3 and Q1. And then standard deviation, like mean, this is the population standard deviation, and this is the sample standard deviation. So we'll be looking at both. And we're going to talk more about what standard deviation means in just a little bit. All right, so our first objective is to be able to calculate measures of center, and we're going to focus on mean and median. So center is just talking about the middle of a set of data, and we either look at the middle as a value or as a number, its position. So when we're talking about the middle value, we're talking about that average, which is the mean, and we all know to find mean, we add up the numbers and divide by how many there are, whereas finding the middle number is putting the numbers in order and literally finding the middle. And we're going to talk more tomorrow about when we would use which measure of center, because there's specific situations where one is going to give us better information than the other. So go ahead and pause the video and look at our ACT math scores and come up with the mean and the median of both. Alright, so hopefully when you calculated the mean by adding all the numbers up and dividing by the 22 that exists, you found that the average ACT math score was an 18.64. And then when you put the numbers in order, you saw that there were 11 and 11. So the middle of between 18 and 18, well, that's 18. So these 2 measures of center are roughly the same, which is a good indication, and we'll talk more about that later, but you get 18.64 for the mean and 18 for the median. So what if I have a histogram like this, and I need to calculate the mean and the median of that, and I don't have the raw data? So let's keep in mind that mean is just the average, so I add them all up and divide by how many there are, and the median is the middle number. So even though I don't have raw data, I can still use what I have because I am given frequency. So when I see this bar goes up to 50, that means that there were 50 people that scored a 1. And this bar goes to 30, so there were 30 people that scored a 2. 50 people that scored a 3, 40 people that scored a 4, and 25 people that scored a 5. So what that actually means is this would be like having 51s listed, and then 32s listed, and then 53s listed, and then 44s listed, and then 25 5s. So really, what I can do to find the mean is I can think about, okay, I need to add them all up. Well, 51s is 50, 32s is 60, 53s is going to be 150, 44s is going to be 160, and 25 5s is going to be 125. So I can think of it in terms of that grouping to save me some time. So for the mean, so to calculate that x bar, I can think about, okay, I have scores of 1, 2, 3, 4, or 5. So how many 1s? I'm going to have 50. How many 2s? I have 30. How many 3s? I have 50. How many 4s? 40. And how many 5s? 25. So if I add all those up, that's how many total points were earned, and then I would divide it by how many total people took the test. Well, if there are 51s, 32s, 50, 40, 25, then that's how many people took the test. So when I calculate this, so when I add them all up and divide by how many there are, I end up with an average score of 2.79 for the mean. So now I want you to think about what would the median be. And keep in mind the median is the middle number. So half of my data points are below and half of my data points are above. So to calculate that, I need to think about, well, how many data points do I have? So if I have 50, 30, 50, 40, and 25, that's the number of people that took the test. So I want to find the middle of those numbers. So let's see how many people took the test. So 195 people took the test. So if 195 people took the test, so the middle is going to be the 98th person, because that would put 97 people below and 97 people above, and 97 plus 97 plus that 98th person is going to give me 195. So I'm looking for the 98th person. So when I look at this distribution, I know that 50 people are in a 1. So there's 1 through 50 numbers, and then 30 people are a 2. So this last person that scored a 2 is going to be the 80th person, because 50 and then 30 is 80. So if I add another 50 onto that, I get 130. So people 81 through 130 are in the 3 region. So what that means is that the 98th person is going to be right here. So the median is going to be a 3. Because the 98th person is going to be somewhere in that bar. All right, so we have calculated measures of center, both from raw data and from a bar graph or histogram. So I'd like you to please pause the video, and I'd like you to have an interaction. So what are some questions you have? What do you understand? What are you going to need to remember? What's new information? All those things. All right, so now we're going to talk about measures of spread. So we talked about the middle of the data. Now we're going to talk about how far apart is the data, how much does it vary. So spread indicates the variability in a set of data. So we're going to start with the range. The range literally measures the distance between the largest and the smallest data values. So when I look at my set of data, our lowest math score was a 14, and our highest math score was a 27. So my range is going to be my largest minus my smallest, which is 13. So we had a variability of 13 points between our lowest math score and our highest. So IQR, which is my interquartile range. So I still hear that word range in there. So we're talking about a lowest to a highest. But here, instead of talking about the maximum and the minimum, we're talking about quartiles. So when I take that data and I put it in order, I find the median, which was 18, where I had 11 pieces of data above and 11 below, so that made that the median. So then I need to take the lower half and divide it into 2 quartiles. So essentially I'm finding the median of the lower half. So if there's 11 numbers, the 6th number is going to put 5 below and 5 above. So this right here, this 17 gives me 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So that's the middle. So we're going to call that Q1. That's my quartile 1. This is the median, which is essentially quartile 2. And then I'm going to do the same thing, and I'm going to find quartile 3, which is the median of the upper half of the data. So 20 is that case. I have 5 above, 5 below, 5, and 5. So I've divided it into 4 equal parts. So 25%, 25%, 25%, 25%. So my IQR is essentially Q3 minus Q1. So now we're talking about the middle 50% of my data. That's going to be my interquartile range. My range is all of my data. The interquartile is just the middle 50%. How much does it span? So Q3 is 20 minus 17 is 3. So 50% of our class varied by 3. So that gives me a little better picture if I have outliers. All right, my standard deviation. So we're going to talk more about standard deviation in the next section, I believe. But what you need to understand is standard deviation measures the spread about the mean. So it takes data, and it's kind of like an inch or a yard or a foot. It's how we measure something, and it's always in reference to the mean. So it's above or below. So it's going to take my data, and it's going to put it into categories that we measure by standard deviations from the mean. So if something has a standard deviation of zero, that means there's no variability. Everything is right in line with the mean. All of my data, so if my mean was 18, all of my data would be 18 because I have 0 variation. Whereas as the spread gets larger, my standard deviation is going to get bigger. So we're going to talk more about it, and it is a complicated formula. I'll show you what it means by hand, but we're going to use the calculator because it's complicated. So what you need to do right now is with your calculator, and if you don't have a calculator, then just write these steps down so you're familiar with it. But you're going to go into stat. So stat is always the place where we put any data into the calculator. And so stat is the button that is next to the left arrow button. And I'm going to edit. So I'm going to hit enter because I want to put my data into the calculator. So if you have any data in your calculator, you're going to arrow up so that the list is highlighted and then hit clear and enter. Don't ever delete lists because that'll mess with your calculator. So now I'm going to go ahead and enter all 22 values into my calculator. And so once I have all 22 in, I need to pay attention to how many variables are we measuring. Well, we're just looking at ACT math scores. I've only put things in list 1. So when I go back to stat and I'm going to arrow over to calc, I want to calculate one variable stats. I'm going to get information about that list. So when I hit enter and then enter again, it is going to calculate all sorts of information about it. So if you notice, the X bar, which we're familiar with, is 18.64. So that mean we were right. If I added all the numbers up together, I would get 410. That's what that summation is. And we're going to skip down, and I just want you to arrow down. N is the number of observations, so I can see that there are 22 data points. The minimum is 14, Q1 is 17, which we were right. The median is 18, Q3 is 20, and the maximum is 27. So my calculator can calculate a lot of this stuff for me. But right now we're going to talk about standard deviation. So standard deviation can come from 2 places. So standard deviation of the population is when we use that Greek letter, is sigma. And it's the lowercase. You may hear sigma as the summation symbol, but this is the lowercase sigma. And so if we were looking at our class as the population, meaning that's the only students that we're talking about, and we have data on every single person, then we're going to use sigma to represent the standard deviation. So in this case, you should see sigma of x is 2.96. Okay, we also have this idea of the standard deviation of a sample. So oftentimes when we want to predict about a population, it's impossible to ask every single person in that population. So if I wanted to know what percent of Americans had been to college, it's impossible for me to ask every single American, so I ask a sample that will represent. So whenever we're talking about the standard deviation that's coming from a sample, meaning that group is going to represent a larger group, that's when we use S as our standard deviation. And so if you notice, S as our sample standard deviation is going to be 3.03. And we're going to explore the difference between those two, but just know that I do have two different standard deviations that I might be talking about. And that's going to measure my spread about the mean. And we will talk more about the bell curve and what all that means. All right, objective 2 is calculating measures of center and of spread. So go ahead and pause the video, have an interaction, write down any questions or things that you're going to need to remember. All right, so you're going to hear this thing called a 5-number summary. And the 5-number summary is simply this down here. It is the minimum, Q1, the median, Q3, and the maximum. So we already know the minimum, which was 14. We know the maximum is 27. And we calculated Q1 was 17. The median was 18. And Q3 was 20. So if you notice, that's 5 numbers. That is all the 5-number summary is. The minimum, Q1, median, Q3, and the maximum. All right, so outliers. We talked last section about guessing when some outliers were by observation, but now we're going to actually have a formula. And so an outlier is just any extreme observation. So what we're going to do is we're going to think about this data, and we're going to look at where does the majority of the data lie, and then how far is too far out for it to be part of the normal distribution, and when is it a significant value. So we're going to give kind of this range that's appropriate, okay? And so we are going to use, if you notice, the formula uses the IQR, so the interquartile range. So the interquartile range is Q3 minus Q1. Okay? So when I do 20 minus 17, I get 3. So my first step is to do Q3 minus Q1. And then I'm going to look at 150% of that. So that's that times 1.5. So once I do Q3 minus Q1, I'm going to multiply it by 1.5. All right, so I'm going to do 3 times 1.5. And I get 4.5. So what that 4.5 means is that we're saying from Q1, an acceptable value would be 4.5 below that. And from Q3, an acceptable value based on our data is going to be 4.5 points above it. So when I think about 17 being right here and 20 being right here, I'm going to subtract 4.5 from Q1. So Q1 minus that value right there. And then I'm going to take Q3 and I'm going to add that value right there, because that's going to give me my acceptable range outside of 50% of my data. So if I took 17 and I subtracted 4.5, I get 12.5. So we're saying that any value from 12.5 to 20 plus 4.5, which gives me 24.5. We're saying those, based on our data, that's an acceptable range of values. So anything less than 12.5 and anything greater than 24.5 is going to be considered an outlier. So if my lowest value is 14, that would be right here in my acceptable range. However, we had somebody score a 27 on the math, which is outside because it's larger than 24.5, so that is going to be an outlier. None of my other values, because my next highest value is 24, that would be right here before 24.5, so actually 27 is going to be an outlier. So again, I did Q3 minus Q1, and then I multiply that value by 1.5 because we want to say 150% of that difference is acceptable to be outside. So then I took Q1, which is my lower, and I subtracted it because I wanted to find out what's my left hand kind of range. And then Q3, which is my upper quartile, I added it to see what my upper window would be. And then I looked for any numbers that fell outside. All right, so now you know how to identify outliers. Go ahead and pause the video and write down what are you going to need to remember, what steps, what questions do you have. All right, so as you remember from your summer project, box plots, that is going to use that 5-number summary that we came up with. So the first thing that I need to do is I need to make a number line. And I need my number line to go from 14 to 27. And once I have my number line, I'm just going to put the 5-number summary on there. So 14, 17, 18, 20, and 27. And I connect the whiskers, and I make the box. And there is my box and whisker plot. So what this tells me, and this is really important that you understand, is that 25% of my data, since we divided it into quartiles, into 4 even parts, 25% of my data is there, 25% of my data is there, 25% there, and 25% here, because you will be asked questions about interpreting this. So 50% of my data falls inside the box, and then 50% of my data is below the median, 50% above. So what I can see is that this is the same amount of data between 17 and 18. So the same amount of people scored between 17 and 18 as did between 20 and 27. So this is more spread out with the same amount of people. So it allows me to see where the numbers concentrate more. And here's a visual that just kind of shows how it happens. So if you notice, the same amount of dots are in each of these quartiles, and they just spread out more. So that's why this is longer than this right here, even though the same amount of data is inside each of those quartiles. All right, so we need to be able to interpret and compare box plots. So the first thing we want to do is we just want to wrap our brain around what's happening. And I left some kind of hints up here. When you're comparing box plots, you want to look at minimums, maximums, median, IQR, things like that. And that's what you can use to compare them. So what's happening here is we're referring to the box and whisker plot. Ignore those questions. To compare homework time per night with TV time. So when I look at this, this is a group of sophomores. They were all interviewed and asked, how much time do you spend watching TV each night and how much time do you spend doing your homework? So I can see that this box and whisker plot represents homework time and this represents TV time. They both start at 0, and I see the median time is 60 minutes and here would be 48. The maximum is 190 of homework and 225 for TV time. So we're going to go through and answer these questions true, false, or cannot be determined. So go ahead and pause the video and see how many of these you can answer on your own, and then we'll go over what the answers are. All right, so some sophomores didn't watch TV that month. So when I look at this, I can see for TV time that there were some data points that fell at the 0. That was my minimum. So that means that there were some that watched 0 minutes of TV. The TV time box plot contains more data than the homework time box plot. So that is false. And the reason that they say that is because some people might look at this and see that it's larger, so they'll think, oh, there's more data. But if you notice, it's the same group of sophomores. The same number of students were surveyed, and they both reported their answers for both times. Now, if they hadn't said the same group of sophomores, then my answer would actually be cannot be determined. Because one of the drawbacks of a box plot is I can see how the data falls, but I can't see specific data points. So I know that 25% of my data is in each of these quartiles, but I don't know how many that is. Is it 1 in each, or is it 5 in each, or 30 in each? I don't know how it falls. I just know what percent. All right, 25% of sophomores spend between 48 and 60 minutes on homework per night. So when I look at homework, between 48 and 60, that is 1 quartile, and that is 25%. So that is true. The sophomores surveyed overall spent more of their time doing homework than watching TV. All right, that one is false. And that one is kind of getting at that idea of comparing box plots. And I want to jump down to 5 and then come back to 4. So when I look at 5, 50% of the students spent as much time watching TV as 75% of the students spent doing homework. So watching TV, 50% of my students. So from 0 to 60, and I noticed that 60 was a 5-number summary for both of them. And so when I look at that, each one of these has a fourth, or 25%. So this one has 3 25% pieces, so that'd be 25, 50, and 75. So from 0 to 60, 75% of the people surveyed spent that much time doing homework. Whereas for TV time, this is only 50%. Because there's 25% here and 25% here. So this was a true statement that 50% of the students spent as much time watching TV as 75% of the students spent doing homework, because they both had that 60 as a 5-number summary point, which helped me then answer this question even more, or to be able to justify. So this, not only did students spend more time, the student with the most time on TV is higher than the maximum for homework. So when we're comparing, we look at maximums. Minimums are the same. The median, so the average, that middle number was 60 minutes spent watching TV, where the average middle number was 48 for doing homework. So TV time had a higher maximum. It also had a higher median. And then the IQR. So it is a wider IQR than this one, because it's 110 minus 15 versus 60 minus 20, that IQR. And also this point that we got at before, that 50% of the students spent as much time as 75% of the students did doing their homework. So I was able to say false to that. All right, these are the advantages and the disadvantages of a box plot. The box plot is able to summarize large data. It's easy to see outliers. It divides the data into quarters, so for comparison, so like we just did. And I'm able to see where the median is in comparison to the data. So is it right in the middle of the data, the value of it, or is it off to one side, closer to the maximum or closer to the minimum? It's pretty easy to make, and it's easy to compare distributions. The disadvantages, I can't see those exact values. I can't determine how many data points are included, so how many people were surveyed. The mean and the mode can't be used, and we can only use it for quantitative data. All right, we are done with our objectives, so go ahead and pause the video and have an interaction. What are you going to need to remember about creating and interpreting box plots? And as always, here's your vocabulary with the definitions just in one place, and I'll see you tomorrow.